And this is something that you do all the time. You look around your room and you organize something. Perhaps your makeup, perhaps your video games, perhaps CDs. Not that most of you have those anymore, but maybe movies. And we just do this naturally. We do this in the outside world too. You look around, you can tell trees from bushes from grass. So let's look at a simple example. If I gave you these words, I want you to mentally, or if you'd like on paper, classify them into 3 groups, exactly 3 groups. Probably most of you picked the same 3 groups, and they probably fell into groupings like this: fruits, vegetables, and American football teams. Classification. Classification is the grouping of information or objects based on similarities, and there are some examples for you. Taxonomy is more specifically the science of grouping and naming organisms, and taxonomists are the people who actually do the naming. There was a man named Linnaeus, and he's the father of taxonomy. He created the classification system that we use today in a slightly modified form because of DNA and other newer inventions, but we still have a 7-layered system, and it still goes from very broad to very specific. Now, Linnaeus' system was based on physical characteristics. Now we do use DNA to ensure that animals are placed into the right category. But to keep it simple, we're going to generally speak about the physical characteristics of the animal so that I can show them to you. Since we don't know a lot of genetics yet in environmental science, we'll try to kind of stay away from that, but I did want you to know that the modern systems do go on genetics and DNA. Here's an animal which many of you may never have seen. Its scientific name is Puma concolor. The reason that I name it by its scientific name is because as you travel around the United States and indeed around the world, it gets many, many colloquial names. So the mountain lion is also the puma, is also the catamount, is also the Florida panther. Sometimes animals like this get names because of their regionality. It's sort of like soda and pop. And sometimes they get a name like the Florida panther because it allows an area to say that regionally speaking, this reasonably common, at least concern animal is actually endangered. So in Florida, Puma concolor, which is very, very common in the Rocky Mountain area, is actually classified as an endangered subspecies. So again, sometimes the naming is done because you're in an area, soda versus pop, and sometimes it's done to denote a subspecies that is trying to be nationally or locally protected. Why is Linnaeus' system so important? It's really important for 2 ways. Number 1, as you can see with the rows, a single plant used to have very long, very complex names. Also, as you moved around from conference to conference or from area to area, scientists in different areas or different countries would name an animal based on what their country called it. And so this led to confusion at conferences, scientific and otherwise, and also when people were trying to protect an animal that was endangered across a border. So in short, this naming system gave us a way to say, okay, we're going to use a dead and ancient language, and we're going to give them a very, very short name that only refers to one animal. In other words, every single animal in the world gets a different name. So do plants, so do insects, so do bacterium. So I want you to imagine it like your name is unique. You are the only person in the world that's able to have it. So we know that this isn't true. For example, my name, Christine Cacosa, there is a woman in Italy who shares the exact same name, and she's a mathematical doctorate. So we know that people's names do not refer necessarily to one single individual. But when we talk about any kind of naming system from Linnaeus, when we talk about the scientific name of the animal, it's only going to refer back to one very specific animal. In other words, Puma concolor is the animal pictured a couple of slides back, and only that animal. So here is the actual naming system. It goes from kingdom to species. Now, after Linnaeus made his system, we did end up coming up with some broader categories. If you look at the right, you can see under kingdom, we have domain and life, and we will come back and talk about domains later on. But for now, we're going to restrict ourselves to kingdom through species. Basically, the definition of any of these words is essentially, it is the entirety of the word that falls below it. So for example, what is a kingdom? A kingdom is made up of all the phylums. What is a phylum? A phylum is made up of all the classes. What is a class? It's made up of all the orders. And so if you look at the right-hand side, you can see the phylum Animalius, and this is literally all of the classifications for anything that falls underneath an animal. For example, if you look all the way to the right, you see the word chordata. The word chordata means has a backbone, and so this is any animal that has a backbone. So that would be you and dogs and cats and ferrets and pumas, but it would not be things like spiders or worms. They would fall underneath another category. So for example, worms fall under nematoda, and spiders would fall under arthropoda. Let's just talk about one very specific species, Canis lupus, or the gray wolf. Let's start up at the top at kingdom. And let's talk about what makes each of the animals in this area the same. A kingdom is an extremely broad classification. Basically, what all animals have in common is that they are eukaryotic. And eukaryotic means that they are multicellular and that they have a nucleus. So every single animal that you see up there is multicellular and has a nucleus. Beyond that, their characteristics are going to differ dramatically. Let's go down to the next level. This is the phylum Chordata. If you notice, certain people get kicked off the island when we go from Animalia to Chordata. Things like the butterfly, the lobster, the mollusk, the jellyfish, the coral, and the spider. What does everybody who's left behind have in common? Everyone who's left behind has in common that they have a backbone. Now, some of these things are going to look very different. Like you're going to have ones that swim underwater. You're going to have ones that fly in the sky, but every single one of them has a backbone. Now we go down to the class. We go down to the class Mammalia. When we go down to the class Mammalia, we lose things like the bird, which is under Avis. We lose things like the fish and the crocodile, but pretty much everybody else stays. Why? Because they have many things in common. They have fur. I understand that dolphin seems to violate that, but dolphin is a very special mammal in that it lost its actual external fur, though not the ability to have fur, when it went back into the ocean off the land. So it does still have the structures for fur, even if it doesn't actually present with fur. They also all have a thing called an amniotic sac, which is where their young are gestated. They bear live young rather than eggs. So all of these things, oh, and they also feed their young with milk. So every single animal in the class Mammalia has those characteristics. Now we go down to Carnivora. It should be pretty obvious who gets kicked off the island here. If you say that name out loud, it sounds like a carnivore. So goodbye, Mr. Bat, because you're an insectivore. Goodbye, Mr. Dolphin, because you eat fish and plant life. Goodbye, Mr. Mole. Goodbye, Mr. Skunk, because both of you are omnivores. So anybody who's not a strict carnivore gets kicked off the island. Now we go down to the family Canida and the genus Canis. As you can see, these are basically going into more and more wolf-like or dog-like characteristics. And when we finally get to the bottom one, the species Canis lupus, we have only one animal, the gray wolf. Here's another one, going through Panthera leo, or the African lion. Obviously, it's an animal with a backbone that bears live young and nurses that young on milk. It eats meat. It is like a cat. It's like a very specific type of cat, And then Leo is the thing that differentiates it from all other panthers. Remember, we had Puma concolor, which would be related down to the order. Obviously, the mountain lion is not the African lion. Thereby, it has a different genus and species. This is how I remember Linnaeus's naming system. Now, please, you know that you all remember things better when you make your own. So in a second, I'm going to pull up a blank slide, and I'm going to ask you to pause the video and to come up with your own individual way to remember this. I'm going to tell you this honestly. Every time I do a question on taxonomy, I literally say in my head, King Philip came over for good soup. That way I make sure that I know my naming system. And so if I'm looking at a chart that's giving me the relatedness of different organisms, I will literally say, okay, let's go down the list and let's figure out, they have the kingdom, they have the phylum, they have the class, they differ in order. Okay, they're the same down to class. But to be able to do that, I need to know which order they come in. Please make sure that you figure out your own way to memorize this. So here we go. That probably wasn't long enough for you to come up with your own. So pause the video, come up with your own naming system that you can think about as we move forward. Scientific names. Why would we use a dead language? We do so for two reasons. Number one, because Latin isn't changing. It is a non-spoken or a dead language, and so is Greek, non-spoken dead language. We're talking ancient Greek, not modern Greek, which is quite a bit different. This leads to two things. Number one, the language doesn't change, and number two, nobody feels left out. Imagine if we did all of our naming in Chinese or Russian. The Americans would say, why aren't we naming it in English? And if we named in English, the Russian or the Chinese or the Germans would say, well, why aren't we naming in our native language? So to keep everybody on the same playing field, to keep all scientists talking the same language, we choose a language that doesn't change, Greek and Latin. So here is a properly named beetle. I want you to look at the way that we name this animal, and I want you to think to yourself, there have to be rules. Look at the correctly done name that's to the right of the beetle, and think about what kind of characteristics it has.